we're going to determine what the mean proportional in right triangles is. So watch this. The altitude to the hypotenuse of a right triangle is the mean proportional. Aha, that's what I wanted. The altitude, okay, to the hypotenuse. This is the hypotenuse of the big triangle, okay? This is the hypotenuse right here of the big triangle. And how do I know AB is the hypotenuse? Because it is opposite to this right angle. So this is the altitude. The altitude, okay? Why is this red and not... So basically everything I do is still gonna be black? Yeah, oh, okay, whatever. So, the altitude to the hypotenuse of a right triangle is the mean proportional between the segments into which it divides the hypotenuse. So, CD is gonna be the mean proportional, right? Correct? CD is going to be the mean. That's what it says. So we just follow our formula. Remember, these are the means. And then it says, what is the mean proportional between the segments into which it divides the hypotenuse. The segments into which it divides the hypotenuse. So we will start this big segment over the mean. So this becomes one of the extremes over the mean. And guess what? This is another mean, so over the other extreme. Alright? And that is for the altitude. So the altitude has to do with segments of the hypotenuse. Alright, cool then. Guess what? Now we have another theorem. It says each leg of a right triangle, each leg right here, each leg, not the hypotenuse. Each leg of a right triangle is the mean proportional between the hypotenuse, okay, and the projection of the leg on the hypotenuse. The what? Projection of the leg. I don't get it. Come on, the projection of the leg is nothing more than the other leg of the right triangle. For example, forget about the big triangle. Just focus on this triangle. So, this is the leg of the big triangle, and this is the projection. Leg, and then projection. In other words, watch this. The projections are nothing more than the segments of the hypotenuse. So, how do I write this down? Watch this. AB, okay? First of all, each leg of the triangle is the mean proportional. The leg. So, let's talk about this leg right here. Okay, that leg is AC. Okay, so each leg of the right triangle is the mean proportional. The mean. So I have, for example, my little box here, my other box here, my box here, and my other box right here. Okay. So where are the means? The means go right here. See that? This is where you put the means, right? The mean proportional. And this is where you put the extremes. Okay, so this is where you're gonna put the leg. Alright, so let's take the leg CB, for example. CB, or you know what? No, let's take AC or CA. Yeah, let's take CA. So this becomes the mean, so CA goes here. Okay, and now is the mean proportional between the hypotenuse, which is what? The big one, and the projection of the leg of the hypotenuse. The hypotenuse is AB. Okay? And the projection of the hypotenuse is right here. So that's AD. So AD goes here. Hopefully I did a good job. Alright, so anyway, you got the rule right here. So look, hypotenuse, the leg that you're working with, the same leg that you're working with, and the projection. So if I'm dealing with this triangle, if I'm dealing with this triangle, this is the hypotenuse and this is the projection. If I'm dealing with this triangle, then this is the hypotenuse and this is the projection. Got it? Nice! Okay, so what else do we have here? Alright, let's see if I understood this problem. So we have, they said find x. Alright, so I'm gonna find x. X is where? Is one of the segments of the hypotenuse of the big triangle. Okay, now can I zoom in a little more? No, zoom in, I said. Alright, yeah, something like that. Okay then, so here I have an altitude. So I need the theorem that talks about the altitude. It says that the altitude, okay, let's go over here. Let's talk about the altitude. Right here. The altitude is what? The mean proportional between the segments and into which it divides the hypotenuse. So the altitude is the mean proportional. Okay, so that's exactly what I'm going to do. So if this is the mean proportional, that means that I'm going to have my fraction, right? So on top goes the extremes. On the bottom goes the means. Okay? So the mean proportional, correct? And now the extremes. Well, the extremes are nothing more than the segments of the hypotenuse. How you like me now? Now we'll cross multiply. Yeah, okay, so I get, this is 64. Okay, so I get 64. What the hell? That don't look like a 4. Okay, 64. All right, equals to 4x. Okay, and now I divide by 4, and I get x equals 16. Okay, that's what you get. All right then. So if they give you the altitude, then you could use the altitude theorem. So using the segments of the hypotenuse. If they give you something like a leg, okay, right here, oops, like they give you the leg, I'm assuming that I'm gonna use the other theorem that has to do with the projections. Let's see. So the leg becomes the mean proportional. Therefore, when I do my fractions, the leg goes here. So this is going to be x and this is going to be x. I have no idea what that is. And on top, here it says that I should put the hypotenuse. Okay, the hypotenuse and then the projection. Well, I'm dealing with this triangle right here. So the projection has to do with this. Has to be dB, which is 2. So you do that. Then you cross multiply and you end up with x squared equaling 16. And you know how that ends up, right? If x squared is 16, I don't need x squared, I need x. So how do I undo the operation of squaring? Well, take the square root of that. And if I take the square root, then I get 4. Make sense? Nice. All right then. So then you have more examples. And here we have the check your understanding, which is basically part of your handout. But we're going to do that. Well, I'm going to do that when I get home. Hopefully it's not too late. Okay. All right, then. So then let's get some practice on this mean proportional of the right triangles. So just remember, if they give you the altitude, that means that you're going to use the altitude theorem. If they give you a leg, then I mean not all the time, you're gonna use the leg theorem. So let's see now. Find x. They want me to find x right here. Not a problem. So they are giving me an altitude. So what I'm gonna do is I'm gonna use the altitude theorem, which says that the altitude is the mean proportional between the segments of the hypotenuse of the big triangle. All right, so I set up my little fractions. So one fraction and the other fraction, the equal sign. And what do I know? That the altitude is the mean proportional. So this is x right here, and this is x right here, because that's for the means of the proportion. Now we are talking about the segments of the hypotenuse. So this is gonna be 9. This is gonna be 4. All right. So now we just cross multiply. So when we cross multiply, We get x times x is x squared. Okay. And 9 times 4 is 36. Guess what? They want me to find x. They don't want me to find x squared. So I need to get rid of this square. So what is the undoing of squaring a number? Well, take the square root. And x is 6. Therefore, the right answer is choice number 2, which is 6. Okay, let's move on to the next problem then. Find x again. All right, so we have the answer right here. But let's see what's up. They are giving me a leg. So I am going to use the leg theorem. And the leg theorem says the following. That the leg is the mean proportional, okay? The mean proportional, so x under here and x on top here. Now, the leg is the mean proportional between the hypotenuse, which is 12, you could see it right here, and the projection of the hypotenuse. The projection is the leg that you're working with right here. So that's 4. Okay, so now when we cross multiply, we get x squared equaling to 12 times 4 is 48. All right, but unfortunately, I don't want x squared. I want x. So I have to undo the squaring by taking the square root. Okay, so x becomes the square root of 48. But then again, none of the choices look like square root of 48. So I have to simplify the radical right here. The simplification is nothing more than finding two factors. One having the perfect square root, okay? And the other one just being a number that doesn't have it. So 48 would be 16 times 3. Okay? Now, square root of 16 is 4. And of course, square root of 3 doesn't have one, so x is square root of 4 square root of 3, which is right here. Move on to the next problem. All right. So once again, you have the answer right here. Now it says find x. Well, what do I have here? Well, let's take a look at this triangle in the following way. Let's take a look at it like this. Okay? Now if you look at it like that, tell me, which theorem are you going to use? Are you going to use the altitude theorem or are you going to use the leg theorem? Okay? Well, depends on what you need. In this case, I want to use the leg theorem. The leg in this case, you see, this is the big triangle right here. So the leg is 5, and the projection is x, and the hypotenuse, which is opposite to the right angle, is 10. So now let's actually put it the way it's supposed to be. So the mean proportional is 5. So 5 under, 5 on top. Cool. The whole hypotenuse is 10. The projection is x. So now I am going to cross multiply, so I get 10x equaling 25. All right, and now I'm just gonna divide by 10. So 25 over 10. Well, dividing by 10 moves the decimal point one place to the left. So this is 2.5. Ah, nice, right? Cool then. Let's move on to the next problem. Okay. By the way, I'm not dead yet, so I can still record at home. All right. So here, find x. All right. Find x. Gosh, I have to find all that. Not just x. What am I gonna be using? Am I gonna be using the leg theorem or am I gonna be using the altitude theorem? Well, let's use the altitude theorem. That's what it makes. That's what it says over here. That's what I have, and I have the two parts of the hypotenuse. So I'm going to write the mean proportional. So fraction equals sign fraction. So the mean proportional is the altitude. So 6 over here and 6 over here. And now remember what the theorem says. The altitude is the mean proportional between the segments of the hypotenuse. What's up?
I want to cut the cake.
You cannot cut the cake right now because I am recording. Okay? Wait till I finish, okay? Don't me. Alright. So let's see now. What did I say? Oh yeah. The segments of the hypotenuse. So the first segment is x plus 5. The second segment is
x. Now we cross multiply. Remember, if you're gonna cross multiply, you're gonna have to use the distributive property. Okay, so that's exactly what I'm gonna do. So x times 5 is 5x. Okay, x times x is x squared. So I just use the distributive property, equaling 36. Funny thing now is that this is a quadratic equation. And if you're my student, then look on the wall and you will see that there is a poster over there that some of you wrote that says that all quadratic equations must be equal to 0. So I want to equal this to 0. How do I equal that to 0? By subtracting 36. So let me rearrange this in order. So first I write the x squared, then the plus 5x, okay? And now minus 36, because I did subtract 36. Now what happened here is that it became 0. Nice. Now I proceed to factoring. So let's factor. What are the factors of x squared? Well, x and x. I need two numbers that multiply, I get negative 36, and when I add them, I get 5. Well, the factors of 36 are 6 and 6, but 6 and 6 will never give me 5. What about negative 4 and positive 9? Yep, negative 4 times 9 is negative 36, and negative 4 plus 9 is 5. Alright, and that is supposed to equal to 0. Now, guess what? I have to equal each of these factors to 0, so not a problem. What number minus 4 is 0? Positive 4. What number plus 9 is 0? Negative 9. Distance is always positive, so we reject the negative value and we utilize the positive one. So x equals 4. Had they asked you what is the length of the hypotenuse, you would have to plug in 4 right here. So this would be 9, okay, right here, sorry. This would be 9 plus 4. The hypotenuse would be 13, all right? But it's not. They just want you to find the value of x, so that's it. Let's move on to our next problem. So here, in the diagram below, the triangles are similar, all right, and they give you the measures. Now they want you to determine the length of AB. Okay, they want you to determine this length. So what am I gonna do? Easy. Look what I can do. You can compare two sides of one triangle to the corresponding two sides of the other triangle, or you could compare side to side. All right. Here, what I did is I compared this side and this side and this side to this side and this side. So I got x plus 2 over x equal x plus 6 over 4. Then I cross multiply. So I ended up with this quadratic equation. Quadratic equations must be equal to 0. So what I did is I subtracted 4x and I subtracted 8. And this is what I end up with. X squared plus 2x minus 8. Okay, equal to 0. Then I proceeded to factor. Factors of x squared is x and x. And then two numbers that multiply give you negative 8, and when you add them you get 2, 4 and negative 2, and that is equal to 0. Then guess what? X equals negative 4 and x equals positive 2. We reject the negative answer because distance cannot be negative, and basically the length of AB they wanted, right? Okay, AB is x. Oh, okay, so then the value of AB is 2. Now let's say you didn't want to compare two sides to two sides. Let's say you wanted to compare one side to one side. Okay, so I would have done the following. X plus 2, this side to this side is compared to x plus 6, okay? The ratio of x plus 2 to x plus 6 equals the ratio of AB, which is x, to the length of that. Guess what? Same thing. You have to cross multiply. So when you cross multiply, you end up with 4 times x plus 2 equaling x times x plus 6. Okay, cross multiply. See, 4 times this and x times this. When you use the distributive property, you end up with 4x plus 8 equaling to x squared plus 6x. And once again, you have to make one side equal to 0. Notice the only difference is that this is on the right side and here I have it on the left side. But then everything else holds the same. So basically from here, you move on to here and then you factor and then you end up with your choice. Okay? So, I'm gonna be nice. Okay. Plus minus 4, so 6 minus 4 is 2, so 2x, okay. And then minus 8 equals 0. And then you proceed to factor, and you know the rest. Okay. Let's move on to the next problem. Okay, here. In the diagram below, the length of the legs of AC and BC of right triangle ABC are 6 centimeters and 8 centimeters. Respectively. The altitude CD is drawn to the hypotenuse of triangle ABC. Alright. So basically this is taking us back to the theorems that we were discussing a little while ago. So they want the length of AD. Alright. So what am I going to use here? The altitude. Okay. Remember something. Just because the triangle is like this, you got to look at the big picture. You want to turn it around. If you turn it around, then it looks like the diagrams that we had on the theorems. So what am I going to use here? Am I going to use the altitude theorem or am I going to use the leg theorem? I believe I'm going to use the leg theorem because I don't have the altitude. Alright, perfect then. And remember, if you're using the small triangle, this becomes the projection. If you're using this triangle, then this becomes the projection. Anyway, the problem here is that I don't have, in order for me, okay, let's use the leg theorem. The leg theorem, in order to find AD, so I'm going to use this little triangle, right? In order to find AD, I have to use the leg theorem, and the leg theorem says that the leg is the mean proportional, okay? The leg is the mean proportional to the hypotenuse and the projection. But I don't have the hypotenuse. Okay. So then let me find the hypotenuse. Now, I know the hypotenuse is 10. How? Because this is nothing more than a 3, 4, 5 right triangle. How do I know that? Easy. Take half of 6 is 3. Take half of 8 is 4. So then half of this must be 5. Now, going back to the real measures, this is double that and you get 6. Double that, you get 8. Double 5 and you get 10. But let's not guide ourselves by that, and let's use the Pythagorean theorem to find the hypotenuse. Alright, so c squared equals to a squared plus b squared. Now c squared, I don't know what c squared is, so I'm gonna keep it as c squared is equal to a squared, which is 6 squared plus 8 squared. C squared equals to 36 plus 64. C squared equals to 100. I don't want c squared, I want c. So I have to undo the squaring, so I take the square root and c ends up being 10. Right, now I know the hypotenuse is 10. So now I can use the leg theorem. The leg theorem says the following, that the leg is the mean proportional. So I set up my fraction and I know that the mean proportional goes in the bottom here and on top here. So 6, 6, and then the hypotenuse is 10, and then the projection of the hypotenuse is x. So I put it right here, and now I cross multiply, so I get 10x equals 36. I divide by 10, and x equals 3.6, and boom, you have it right here. Alright, let's move on to the next problem. So we have it here. Alright, so here they want you to find the length of AD. They want you to find the length of AD. So I'm going to call this x. Right away, I know I have a leg, and they ask me for the projection of the hypotenuse. So I'm going to use the leg theorem. So the leg theorem says that the leg is the mean proportional. Okay, so I set up my proportion, okay? So the mean goes in the bottom and then on top. The length of the hypotenuse is 36. The projection is x, I have no idea. I'm gonna cross multiply. So when I cross multiply, I get 36x. Look, 12 times 12 is 44. So I get 36x equals 144. I'm gonna write it right here. 36x equals 144. Then I'm gonna divide by 36. All right, so I divide by 36, and x ends up being 4. So x equals 4. Question: they want the length of AD. What is the length of AD? Oh, it's x. So it's just 4. Whew. Okay, it's hot in here. So, okay, so they give us this, well, we're on the same topic. So they gave us this triangle with these measures, and they want me to find the length of BD. They want me to find the length of BD. BD, they want this. Guess what? This is the, what do you call that? The projection. So I guess I'm gonna end up using the, what do you call that? The leg theorem. But unfortunately, the leg theorem says that it is the mean proportional to the hypotenuse and then to the projection. I don't have the hypotenuse, so I'm gonna have to figure it out. All right, not a problem. So what I'm gonna do is I'm gonna use the Pythagorean theorem to figure out the hypotenuse. Okay, so that's exactly what I'm gonna do. Okay, so let's see now. I'm gonna say the following. So 6 squared, wait, I'm confused. Okay. You know what? Yeah, I'm really confused. They want BD, but it doesn't work like that. Oh, you know what? Nah, not even. I'm not gonna use the Pythagorean theorem. I don't know how to use the Pythagorean theorem, but I'm gonna try it using the leg theorem. So I'm gonna set up my two fractions, right? The mean proportional is the leg, so it's gonna go on the bottom and on top. Now the hypotenuse is 5 plus x. I hope this works. See that? 5 plus x. And the projection is nothing more than x. Okay, so I'm gonna cross multiply. When I cross multiply, I end up with 36. No, let's multiply this first. So I get x squared, because x times x is x squared, plus 5x, okay, equaling 36. Now this is a quadratic equation, so I have to equal it to 0, so I'm gonna subtract 36. Now it's equal to 0, so I'm gonna factor. And I reject the negative solution, so x is 4. So the length of BD is 4. On the regions and on a test, you're right, the length of BD is 4. Okay, you just don't leave it like that. All right, let's move on to the next problem. Okay, here again. Just because this triangle is upside down, you can just look at it like this. Okay, look at it like that. So they want the length. They want us to find the length of BD. They want the length of BD. They want the altitude. The altitude. All right. So let's see how to do it. So the altitude is going to be x. What do I know about the altitude? The altitude is the mean proportional between the segments of the hypotenuse. I don't have the segments of the hypotenuse. All I have is one little segment and the whole. Oh, wait. But if the whole hypotenuse is 16, then that means that this is 9. Okay, 9 plus 7 is 16. Okay, now I can use the altitude theorem. So the altitude is nothing more than the mean proportional between the segments of the hypotenuse. All right, so I'm gonna set up my my thingies. I'm gonna do it over here. You could do it anywhere else. So I set up my two fractions. Okay. So the mean proportional is the altitude, so this is going to be x and x in the bottom and on top. And then to the segments of the hypotenuse, 9 and 7. Now I cross multiply, right? When I cross multiply, I get x squared equaling 63. Okay? So which is what I have here, x squared equals 63. I don't want x squared, I want x, so I take the square root of 63. Okay? Now, look at the choices. The choices are in radical form. So that means that 63 must have some type of radical form. Okay, so I find the factors of 63 in which one of them has a perfect square root and the other one doesn't. 9 and 7. Square root of 9 is 3. Okay? Let me just write it correctly. 3, and then radical 7 is just radical 7. Okay. Let's move on to the next problem.
Listen.
Be quiet. Okay. In the diagram below of triangle ACB, okay, you know what? What is it that they want? If AD is 3, okay, we got that. DB is 4, we got the measures. Find the length of CD. CD. Alright, CD. Compact disc. Okay, so I'm gonna call this X. Oh my god, so easy. What am I gonna use? Okay, you know what? Let me start giving points. So I'll give you whatever I want if you answer me the question. What theorem am I gonna use? The altitude theorem or the leg theorem? 1, 2, 3, 4, 5. Time is up. I'm going to use the altitude theorem because I got the segments of the hypotenuse and all I'm missing is the altitude. Alright. What does it say? It says that the altitude is the mean proportional, okay, so in the bottom and on top, to the segments of the hypotenuse. Alright, so I end up with x squared equaling 12. I need to take the square root because I need to find x, not x squared. It says in simplest radical form. Oh, please, I know how to simplify 12. 12 is nothing more than 4 times 3. Square root of 4 is 2, and then 3 is just 3. Okay? So that is that. On the regions, or on the test, you write the length of CD is 2 radical 3. You understand that? Alright, cool then. Let's move on to our next problem. Okay. In triangle PQR, okay, PRQ is a right angle. Okay, so first of all, PQR is a right angle and RT is drawn perpendicular to hypotenuse. Oh gosh. Alright, so what we do is we write, we've been looking at these problems. So whenever they say something about similar, whatever, so we want to do this. PQR. PQR. I don't know. Angle PQR is a right angle. Sorry. Angle PRQ. PRQ is a right angle. Oh gosh, I did it wrong. And RT is drawn. RT is drawn. Okay. So next time, don't be stupid, Becker. Why do you have to, you don't have to delete the whole thing. You just have to relabel it. PRQ is a right angle. PRQ. Okay. PRQ is a right angle. This is the right angle. Becker, why didn't you draw the triangle? Oh, wow, you were not looking. Okay. This is the right triangle, and this is PRQ, saying that it's a right angle. All right. Now let me make this smaller so you can see. Okay. Now, Becker, why didn't you make this like a triangle like this? Nah, because that's not the way it looks. Because we have to put, you see, like this one? We're going to have different right triangles. Oh, okay. So then what else this says? It says that RT is drawn perpendicular to the hypotenuse, PQ. Okay, RT right here. Perpendicular. This is T now. To hypotenuse, PQ. But you see, now once you know how to label it, then everything falls into place. PQ, okay. PT is X. PT is X. What else? RT is 6. Right away I know I'm gonna use the altitude anyway. And TQ is 4x. TQ, 4x. Definitely, I'm gonna use the altitude because they're giving me the segments of the hypotenuse and I got the altitude. Okay, so what is the length of PQ? The length of PQ? Sure. So let us use the altitude theorem. So the altitude theorem says that the altitude is the mean proportional, so in the bottom and on top, to the segments of the hypotenuse. Segment. Cross multiply and you get 4x squared equaling 36. Divide by 4 and you get x squared equals 9. Okay, take the square root of that because you gotta undo the squaring, and x equals 3. So the length of PQ, okay, PQ is nothing more than 3 and 4 times 3. So that's 3 plus 12 is 15. So guess what? Look, 5 times 3 is 15. So your answer would be, and you write it, the length of PQ is 15 whatever units, centimeters, or whatever. Okay, let's move on to our next problem. Here, in the diagram below, and we got this triangle. They want the length of h. They want the altitude. Oh gosh. So what am I gonna use? I'm going to, okay, do I have the length of the hypotenuse? Yes. Do I have the legs? Yes. So, but I need to figure out what the segments are. Then I have it right here, but I think I want to do it by hand. All right. So 5a, let me see if I have enough space here to actually do the problem. All right. Here I need to find a and b first. So that's exactly what I'm going to do. I'm not gonna erase it. I'm just gonna redo it over, okay? So I'm gonna, first to find the b or the a, okay, let's find a first. To find a, I am going to use the leg theorem, okay? Because I got the leg, I got the whole hypotenuse, and I need the projection. So the leg theorem says that the leg is the mean proportional, okay, of the whole hypotenuse, okay, and the projection, which is a. See, you gotta use your common sense. This is not like mechanical where you could just, okay, yeah, it's the same formula over and over. Yes, but you need to know how to utilize it. So then 5a equals 16. Okay? So there you have it. 5a 16. What is 16 divided by 5? 3.2. So if this is 3.2, then this must be 1.8. Correct? Okay then. So now I can find h. So to find h, I need to use the altitude theorem. The altitude theorem says that the altitude is the mean proportional to each segment of the hypotenuse. Okay, so that's what I get. This is not the right numbers. Blah, 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 blah. Okay. So now I'm gonna cross multiply. So what is 1.8 times 3.2? Okay, that's 5.76. So this is 5.76. I don't want h squared, I want h, so I'm gonna take the square root of this. Okay. And the square root of 576 is nothing more than, I have no idea. So 5.776 is 2.4. So 2.4. And anyway, that's what I had here. But of course I was using a different approach. So that's it. Alright. Thank you. See you on the next lesson.